All right, halogen alkanes are saturated molecules because they don't have multiple bonds, double or triple bonds. There is a polar bond happening because the halogen is going to be more electronegative than the carbon, so the electrons within the bond between the halogen and carbon will be more with the halogen than the carbon. So the carbon gets the delta positive. Sometimes it's referred to as electron deficient since the halogen has pulled the electrons towards it. Nucleophiles are reactants that are electron rich due to a lone pair of electrons and a negative charge, and hydroxide is really the only one that you should probably be concerned about. They're attracted to the electron deficient carbon, and so you have the hydroxide that's going to come in here and replace the bromine. So this is like a substitution reaction of the halogen. And so you're going to see halogen alkanes specifically with CFCs, which is destructive towards our ozone layer, and we've talked about that. There's more info on page 196. So if we look at an example, chloromethane, so methane, we have one carbon and then there's a chlorine on it. And so the chlorine, being more electronegative, is going to attract those electrons in the bond, so it becomes partially negative and the carbon is left being partially positive. And so you could redraw the molecule like that, where the electrons are on the chlorine, and then we have this positive, we're missing that. And then sodium hydroxide is ionic, so it's going to dissolve in water, or it's going to break into its two ions. The sodium then will attract the chlorine, and the hydroxide then is going to be attracted, that negative is attracted to that positive. So we end up with methanol and sodium chloride as our two products.